In this video, let's learn about how to spawn manipulators and control them. Since we already learned how to import custom objects and change their physical properties, it's time to pick and place those objects with our manipulator. Moreover, in this video, I will show you how to collect data from Isaac Sim, and after collecting data, you can use those for robotics AI models and implement tons of fancy applications. And this project contains several examples, so you can switch between them by commenting and uncommenting from this extension.py Python file. So for our first example, now I'm uncommenting first one, hello underbar 1. All right, let's dive into our first example from Isaac examples and load balance EDU. Click this button. Example 9, hello manipulator. Click this load button. Okay, if I run this simulator in this example, I will show you how to spawn a manipulator first and how to control its gripper. So if you launch this example like this, our robot will consistently open and close its gripper. Okay, let's review the code for this example. From the top of this example code, you can find that I'm using Franca package from omni.isaac. So like this, NVIDIA already provides several popular robot models and APIs for their users. So in this setup scene function, we can easily add this model into our scene by word.scene.something. In here, we're adding this Franca robot by word.scene.add Franca robot. But although we're using a predefined API, we need to specify a local path for this robot and its name, like this. So the local path name will be /word/fancy_franca, and its name will be a fancy_franca. After the setup scene function, it's time to run this setup post load function. And as you can see here, this function binds physics step as a callback function. So if you want to implement specific logic in this function, and if you implement something in here, then we can control our robot every single time for simulation time. This example was for gripper opening and gripper closing. So let's find how to control our Franca robot and Franca robot's gripper. This is the official Omniverse documentation. So first of all, every single Franca robot instance has subclass, which is named gripper. And let's dive into this gripper. Franca robot gripper is parallel type gripper, like this. This parallel gripper has an API function that is named set, joint, and position. This one, set joint positions. But Franca robot gripper is a parallel gripper and has only 1 degree of freedom. So to be honest, it is not a positions, but just position. And how do we know and what is the position for opening gripper and closing gripper? Don't worry about that. Parallel gripper class already contains joint open positions and joint closed positions. So all we have to do is just implementing our logic using those variables and those APIs. So now, like this, we can implement our logic for gripper opening and closing. Every 50 simulations tabs, our robot we're gonna open its gripper, and every single 100 simulations tabs, our robot we're gonna close its gripper repeatedly. And at this point, let's check out our robot model itself. Here, Fancy Franca. And to be honest, all we did is just utilizing a predefined model through core API. But if you click this robot and traverse those joint and several tons of joints and this gripper also, then you can find that those kind of magic numbers here. Numbers in here, and numbers in here, and numbers in here. So although our example looks like simple, it requires tons of optimization and trial and errors for this tuning, lower limit and upper limit, and target joint and damping and stiffness tuning, the gain tuning. So please keep that in mind. NVIDIA already did it and provided it for us. For our next example, we're gonna learn the fundamental operation of manipulator. Yes, pick and place. Check out if you changed your example to hello manip2 from this extension.py Python file, and let's launch. Run the simulation, and as a result, you can watch this Franca robot is doing picking and placing. All right, perfect. Great job, Franca. So, okay, now it's time to review our code example. Here, like our previous example, I did add Franca robot into our simulation scene, but in this time, I also added a small cube, dynamic cuboid for picking. And next, here, we can notice a huge difference. That is, we're adding a controller this time. And Isaac Sim already provides predefined and pre-implemented pick and place controller for each robot. So, and you can easily use this by this line. Omni.isaac.franca.controllers import pick place controller. But this video will not explain how this actually works. But in short, this package is implemented by Riemannian motion policy, RMP flow. So in this step, we can easily define pick and place controller by using the pick place controller, and we're gonna use this for controlling our robot, this self underbar controller instance. Eventually, this physics step function, whenever the simulation runs, we gonna get the manipulators joint states and feed them into the controller. And if so, our controller gonna calculate what the robot should be and should do now, given picking and placing positions and current robot's joint positions. And returns actual action commands that is named action. And finally, we can draw these action commands to our robot by robots API. This one, apply action. And check your terminal now. Your terminal here. Okay. You can watch actual action commands. And each action command is formulated with joint positions, velocities, and imports. Therefore, if you want to use your own controller with this robot, you need to convey your own action commands here. Franca.apply action. And let me briefly explain about how this pick place controller works. During pick and place operation and in this terminal, you can find controller event, something controller event 10, 9, 8, 7, maybe 7 there. Yeah, something like that in your terminal. And let's gonna check the actual implementation of this pick place controller. This is the original code from the Isaac Sim. Yeah. So like those commands, this is the pace for pick and place operation. Pace 1, 2, 3, 4, 5, 6 to 9. And if you watch this implementation, like in the commands and here, this controller is a time-based controller, which is given a specific time, specific step time in the robot's current state. It calculates gripper's height and position. And finally, in this function that is in forward, look at this forward function. It calculates actual action commands target joint positions in here, but actions in our example, it returns this value. So eventually, I just briefly talked about how it works, and you can dive into this code if you want to really deep learn everything about this implementation. All right, this was our second example, the pick and place operation. For our third example, let's change the robot and object to pick up. Everything except that is the same as before. Let's run. By the way, this operation we're gonna fail. Robot's motion looks weird and cannot pick up our NVIDIA cube. What happened and how can you fix this? So it's time to go to the code line. Look at this, hello manip3.py Python file. So first of all, in order to change the robot manipulator from Franca to UR10, I did import the UR10 and pick and place controller for UR10 like this from core API. And then instead of the plain blue cube, I added NVIDIA cube like this from Nucleus. So if you learn about how to do this, watch my previous lecture, please. And next, so this is the actual control logic function. So given picking and placing position and current robot status, you're gonna calculate robot's action. But you can find several additional parameters here. First of all, this one, end effector offset. Unlike Franca, UR10's end effector means the endpoint of the manipulator, not an endpoint of the gripper. So which means this place, not a that place. So as we can change the grippers like surface gripper or polar gripper or fingered gripper, we need to modify this value into actual gripping point. So in this case, it was 0.035. And second, this one, end effector orientation. Do you remember that our previous example has failed like this? This is because of the orientation. Franca Panda has 7 degrees of freedom, DOF, but UR10 has only 6. So although we use exactly the same orientation for picking, it doesn't work the same. So we need to specify specific orientation which can make our robot can grip and picking and placing our cube. Save this. Alright, let's gonna try this again. Now I changed the orientation. Look this. Now robot can move it smoothly because of UR10 has less degrees of freedom. Successfully placing. Great job. And again, you can find APIs about UR10 from the core API documentation website and here. UR10 and Universal Robotics. Okay, so far so good. The success of pick and place may depend on physical properties of the object sometimes. So for our next example, let's examine such cases and adjust the object's physical properties to achieve a successful pick and place. When you learn this example, watch carefully. You can see that Franca is trying to grasp our object, but it slides downward during the grasping. And this could be due to either the cube is too heavy or this cube is too slippery. Therefore, we're gonna modify this cube's physical properties. Okay, first of all, I will teach you how to do this by Isaacson GUI. So in order to modify the mass of this cube, click this cube and scroll down, find the mass here. Now you can notice that the weight of this cube is 1.0 kilogram. It's too heavy for this Franca robot. So I'm gonna change this into 0.1. enter. Next, for changing the friction of the specific objects, you must create physics material in here. Physics material. So click light button, create physics material. Since this NVIDIA cube is rigid body object, click rigid body material and OK. And here, scroll down, find this one, physics and dynamic friction and static friction. Yeah, since the minimum value of friction value is 0 and maximum value is 1, I'm gonna modify it into 0.5 and 0.5 also, and click. And next, let's change the material name to my friction. Okay, and for making more pretty, let's change this location in here. All right, now we just added one physics material. Next, we need to attach this my friction into this NVIDIA cube. How can you do this? Click this NVIDIA cube and keep that in mind. Not this NVIDIA cube, but the mesh, exact mesh of this cube. Click this mesh object and scroll down and down and down. You can find this physics tab. And from physics tab, this physics material on selected models, find this one. And if you click these arrows and change this value property into my friction, then you can apply your own material, physics material to your own objects. Okay, now we modify mass and friction. Let's try this pick and place again. Perfect. It works well. Pick and place. Now it runs perfectly. Okay, now it's time to dive into code. Look at this add cube function. And here, now I'm creating this mass property and setting this value as 1.0. So if you want to change this value, if you want to decrease this value, let me something like 0.5 or 0.1, you can modify this value in here. And our robot can easily pick this cube. Next, modifying friction is a little bit more complex and mass changing. First, from this, and here, setup post function, I'm calling this modify cube friction. But in this point, given that this setup post function is an asynchronous function, in order to make this function to execute, I make this function as an asynchronous function too. And in order to call this function, I use this await keyword. Now finally in here, modify cube friction function like we did before with Isaacson GUI, make friction properties, those two friction properties, and attach them to our NVIDIA cube mesh. Like this, I implemented two kinds of different friction materials, high friction material and low friction material, and high friction material has dynamic and static friction 1.0, and low friction material has dynamic and static friction 0.1. So if you want to change this friction from low friction to high friction, change this value from low to high. Quite simple. So in this example, we learned how to modify objects' physical properties for pick and place. And also we learned the logic for this by how to use this asynchronous and await function for Isaacson. Please keep this in mind. Finally, today's last example. Nowadays, you can find many robotics and AI applications like humanoids and autonomous cars and industrial robots. But in order to train an AI model for such an example, robotics examples, you need tons of pre-trained and post-trained dataset. So in this example, I would like to give you a simple example which can collect manipulator data from Isaacson. But before diving into our example, you must install some dependencies And just follow me, please. Open this ISIM Omniverse Launcher and click this launch button and launch this ISIM selector. And in this tab, click this button, Open in Terminal. And then all you need to do is typing this command lines // python.sh -m manually pip install h5 and click enter, type enter. Since I already installed that, nothing happened, but now we're installing h5py package into your local ISIM Python environments. Please do that first, please. And what is the h5py? An h5py is a Python package for HDF5, which is widely used nowadays for robotics applications. So after installing this Python package, you can use h5py in your Python examples, ISIM Python examples, and you need to unzip this hello manify file now. And here, I'm gonna extract this zip file. Okay, you can find this hello manify Python file, and from extension.py, finally we can execute our last example, uncomment and comment this hello manify and save it. It's time to launch our example. Okay, after specific simulation times, look at this, 200 and 300 and 400 and 500, and this time step 500 time step. After these simulation steps, ISIM will automatically stop. In this step, reset your environment, reset, and check out this message, data saved at something.htf. Now you can find this one, robot data underbar your current, time and .htf. So now open the folder, and we're gonna use it, and we're gonna see through how it looks like. And I highly recommend to use something visualization and leading application. And for HDF organization already provided this HDF view program. I'm gonna use this. You can easily install them. They also provide Linux version and Windows version and everything. So from this HDF view, I'm gonna drag and drop this HDF dataset and I expand it. Now you can find it from each time step, from time step 1 to 500 -1, therefore I have 500. You can notice that we collected joint positions and velocities of our Franca robot from ISIM. Okay, so this is the Python code for this example, hello manify. For this implementation, I didn't change the ISIM part, but only added several lines for getting robot data and saving them into HDF5 format. So from class constructor in here, I defined the pilot path and saving location. And from setup scene here, I defined file handler and created group. And all those are not ISIM, but h5py dataset related codes. And finally, in here, our robot Franca already has APIs for getting joint positions and velocities. So all I did was just get them and save them in a format of the HDF. Lastly, and some unexpected situations can happen during file saving, so I made simple exception logic in here. Therefore, whenever you reset your Word, HDF file will be successfully saved and you can enjoy them like this. Okay, from this video and from my previous videos, you might learn tons of ISIM APIs and useful examples. And I highly recommend to trying that by yourself, and feel free to leave any comments. So see you next time. Don't forget to subscribe and liking my channel. Bye bye.